Hello students, welcome to third lecture of D and F block elements competitive. In previous lecture we were discussing about the compounds of D block element iron. Now let's proceed further. So previously we discussed about properties of steel, and in this unit we are going to discuss about the properties of iron. So one point to note here is dry or moist air has no action on pure iron, but when we have impurities in it, it will get rusted. So that means purified iron is protected against the rusting, but however finely divided pure iron burns in air or with oxygen to form Fe3O4, magnetic oxide of iron. And if you check the oxidation state, in this case we have 4 oxygens, so that means we have -8 and we have 3 Fe to neutralize it. That means per Fe we have total 8/3 oxidation state. So as we can see, it is not in integer number, but it is fractional value. So actually Fe3O4 is mixture of two different oxides of iron, FeO and Fe2O3. So overall we have 3 Fe's as we can see here, and total 4 oxygens as we can see here. So 1 mole of FeO plus 1 mole of Fe2O3 gives Fe3O4. And the simple reaction is as mentioned, 3Fe plus 2O2 gives Fe3O4. Now decomposition of iron by ion of steam. So 3Fe plus H2O, it will break down the H2O and it gives Fe3O4 and H2 gas. Now action of acids on iron. Iron reacts with HCl dilute or H2SO4 dilute and it liberates hydrogen. So that means iron will combine with Cl and SO4 with dilute acids HCl and H2SO4. With concentrated H2SO4 it gives SO4, and with dilute HNO3 it gives NH4NO3, and moderately concentrated HNO3 reacts with iron forming NO2. Cold concentrated HNO3 makes iron passive due to the deposit of thin layer of iron oxide on the surface. So just like aluminium, Fe3O4 layer on the surface of iron in presence of HNO3 will protect the iron. Hot concentrated HNO3 reacts with iron liberating NO, and reaction is as follow: Fe plus 4HNO3 hot concentrated gives FeNO3 thrice NO and H2O. Iron does not react with alkalis, and it displaces less electropositive elements Cu or Ag from their salts. So simple reaction as follow, and we can say that from the data of their electrode potential, we can say that copper and Ag, that means silver, both of them are comparatively less reactive than iron. So less reactive elements have tendency to reduce and higher reactive metals have a tendency to oxidize. That's why Cu will be reduced from +2 to 0 and Fe will be oxidized from 0 to +2. Finely divided iron combines with CO forming pentacarbonyl. Fe plus 5CO give FeCO5. Now between the Fe and CO, in this case we have coordinate covalent bond. That means this compound mentioned here is coordinate complex compound. Then iron does not form amalgam with mercury, and iron is the most abundant and most widely used transition metal. And we know that we use iron in multiple different type of things, in construction or household utensils, nut bolts, vehicles, etc. Majority we use iron metals to construct all these things, and our tools are also made up of ions or alloy of ions. Now let's talk about the compounds of iron. So oxide of iron, the iron forms 3 oxide: FeO, Fe2O3 and Fe3O4. Now Fe3O4 is actually mixture of FeO and Fe2O3. In pure state, Fe3O4 as discussed earlier will have 8/3 oxidation state or plus 2.88, which is fractional, and we know that it is not possible. Now ferrous oxide FeO, it is black powdered, basic in nature and reacts with dilute acid to give ferrous salts. FeO plus H2O, H2SO4, it gives FeSO4 and H2O. And FeSO4 is green colored, light green colored crystalline substance. So it is used in glass industry to impart green colors to glass. Now individual ions normally have their definite colors. Usually Fe plus 2 gives green color, whereas Fe plus 3 gives red color. Next, Fe2O3, it is reddish brown powder and not affected by the air or water because already it is its highest oxidation state. Okay, maximum possible oxidation state of Fe is normally plus 3 and it is already plus 3, so now it is resistance from air and water. It is amphoteric in nature and reacts both with acids and alkalis to give salts. It can be reduced to iron by heating with carbon or carbon monoxide. So this reaction carbon or carbon monoxide is actually discussed earlier in the production or concentration of iron or Fe3O4. So Fe2O4 with carbon gives Fe and CO, and Fe2O3 with carbon monoxide gives Fe and CO2. It is used as a red pigment to impart red color to external walls and as a polishing powder by jewelries. So as mentioned, it is red in color. Fe plus 3 ions gives red color, so we can use it to produce red colors in certain compounds. Now ferroferric oxide. So as the name suggests, ferso, that means it represents plus 2 oxidation state, and ferric, which represents plus 3 oxidation state. So normally if you have only 2 oxidation states, then lower oxidation states get suffix OUS and higher oxidation state gets suffix IC. So here we have two different oxidation state, plus 2 and plus 3. That's why plus 2 is ferrous oxide and plus 3 is ferric oxide. So that means this name suggests it has both of the oxidation state of Fe plus 2 and plus 4. And same thing can be observed from here. So Fe3O4 is actually FeO and Fe2O3 combined. So total we have 1 plus 2 Fe, that means total 3, and 1 plus 3 oxygen, that means total 4 oxygens. So it is more stable than FeO and Fe2O3, magnetic in nature and dissolved in acids to giving a mixture of iron 2 and iron 3 salts. Fe3O4 plus H2SO4 gives FeSO4 and Fe2SO4 thrice. So combinedly, just like Fe3O4, we can say that we have Fe3SO4 4 times with H2O. Next is a ferrous sulfide. So FeS or ferrous sulfide, it is prepared by the heating iron filling with the sulfur with dilute H2SO4. It gives H2S. So FeS with H2SO4 gives FeSO4 and H2S. So in this case, it is sulfide compound of FeS. Usually when we dig from the earth crust, we can get Fe in this form, sulfide ore of Fe. Ferric chloride. So ferric chloride is one of the important compound. So preparation, it is prepared by the treatment of FeOH thrice with HCl. It gives FeCl3 and H2O. The solution on evaporating gives a yellow crystal of FeCl3 6H2O. So as we can see, as the second product we have water. So that means by heating the compound we can remove the water, excess water, to get purified compound. Now properties. So anhydrous FeCl3, that means dried form of the compound. Anhydrous will represent dried form of the compound. Forms reddish black deliquescent crystals. Now deliquescent crystal, that means it has tendency to convert into liquid state by absorbing moisture or by itself. FeCl3 is hygroscopic and dissolved in H2O, giving brown acidic solution due to the formation of HCl. Now hygroscopic, that means it will moisture absorbing. When we place it in open atmosphere, it will capture the moist present in air. So that means it will start diluting in water itself. Or suppose you have dried powder of FeCl3, or even we can carry out the practical with NaCl. When we place NaCl in open atmosphere for too long, then it will feel wet after few minutes or few hours depending on the moisture. But FeCl3 is more hygroscopic than that. It will quickly absorb the moisture from surrounding. And reaction FeCl3 which H2O it gives FeOH thrice and HCl. Due to the oxidizing nature of Fe plus 3, FeCl3 is used in etching metals such as copper. And etching, that means we can imprint images on the surface of metal or whatever we have. So we can use Fe plus 3 on the surface of copper to print, or we can say that to carve designs on the copper. So simple reaction Fe plus 3 which Cu gives Fe plus 2 and Cu plus 2. So this aqueous Cu plus 2 is actually converted from the surface, and we can get grooves on the surface of metallic copper because these metal ions are converted into aqueous compound Cu plus 2. Next, in vapor state Fe plus 3 exists as a dimer, that means two different molecules hold together. So in this case, actual FeCl3 first molecule is present here and second molecule is present here. But because of these two chlorines, this chlorine feels attraction towards the next second Fe, and second Fe contains chlorine which feels attraction towards the first Fe, and we get dimer. It is used as a septic to stop bleeding from cuts, that means medicinal use. Then next we have ferrous sulfate FeSO4 7H2O which is green in color, and it is prepared as follow. When Fe reacts with H2SO4 it gives FeSO4. Now when FeSO4 reacts with moisture pressurized air, it becomes brownish due to the oxidation by air. So oxidation, that means we have plus 2 plus 3 oxidation state of Fe. So FeSO4 gives FeOHSO4, that means Fe is in plus 3 oxidation state, OH will be in minus 1, SO4 into minus 2 oxidation state. On heating, crystal becomes anhydrous, and strong heating it decomposes to Fe2O3, SO4 and SO3. So FeSO4 with 7H2O, that means it has very high content of moisture, it gives FeSO4 and 7H2O anhydrous form. Further strong heating of FeSO4 gives us Fe2O3, that means oxidized form of Fe, and SO2 and SO3. It can be reduced acidic solution from KMnO4 to K2Cr2O7. So it will act as reducing agent for these two, and both of these two are strong oxidizing agents. It is generally used in double salt with ammonium sulfate. Now double salt, that means it contains two different type of ionic compounds or salts. So NH4 twice SO4 with FeSO4 in presence of 6H2O gives FeSO4 NH4 twice SO4. So NH4 twice SO4 and FeSO4 both will combine, and combinedly you will get Fe NH4 twice SO4 twice. So Mohr salt is resistant to amphoteric oxidations. Next, it is used in the ring test for nitrate ions, where it gives brown colored ring to of the compound FeSO4NO. So this reaction is also one of the identification test of Fe metal in the mixture. If we have inorganic qualitative analysis practical, in this type of practicals usually you will be provided with unknown inorganic compound which contains one positive, one negative ion. So let's say our compound contains positive ion of Fe plus 2. That means we can use this test to identify presence of Fe. If Fe is present, then you will get colored ring in the test tube. So it is known as a ring test. And similarly, if suppose we are doing organic qualitative analysis, that means you will be provided with unknown organic compound, and let's say it contains NO compound. That means if it contains NO2 minus compound or negative ion, then we can use it. Again, same reaction will be used to form ring test. FeSO4 is used in manufacturing of blue black ink, and FeSO4 H2O2 is known as name Fenton's reagent. So in ring test, this type of ring will be formed when two different solutions mix together. So this is the identification test of nitrate ion NO2 minus as well as for Fe2 plus. If Fe plus 2 or NO2 minus is present in the mixture, then they can give this type of ring together. Okay, so that means if Fe plus 2 is unknown, then we can use this compound to identify. If NO2 minus is unknown, then we can use Fe plus 2 compound to identify. If these compounds are present, then you will get this type of ring. Now Mohr salt FeSO4 NH4 twice SO4 6H2O. It is double salt and prepared by the crystallizing solution containing equivalent amount of FeSO4 and NH4 twice SO4 as discussed earlier. It may be noted that the Mohr salt contains only Fe plus 2 ions without any trace of Fe plus 3. In contrast, FeSO4 always contains some Fe plus 3 ions due to aerial oxidation of Fe plus 2 ion. Aerial oxidation, that means air will oxidize Fe plus 2 into Fe plus 3. Mohr salt is therefore used as a primary standard in volumetric analysis, since a standard solution of Fe plus 2 ion can be obtained directly by weighting a known amount of Mohr salts. That means pure FeSO4 is actually not possible. It always contains Fe plus 3 in trace amount. So for proper idea or proper results, we can use standard of FeSO4 NH4 twice SO4 Mohr salt. It acts as reducing agent and as such reduces acidified KMnO4 and K2Cr2O7 solutions. Now both of these K2Cr2 and KMnO4 are strong oxidizing agents, so obviously they will undergo reduction and Fe plus 2 containing compounds will oxidize. MnO4 minus plus 5 Fe plus 2 with 8 H plus gives 5 Fe plus 3 Mn2 plus and H2O, and Cr2O7 2 minus with 6 Fe 2 plus with 14 H plus gives 6 Fe3 plus 2 Cr3 plus and 7 H2O. Now both of the Fe plus 2 can be obtained from Mohr salt.